All right, so this is going to be a little walkthrough on conic sections. It's IXL P.7, 8, and 9. We're doing ellipses. I want to remind you that there is this document in here. Looks like this. It's pc9, handout on ellipses. It has everything you know. Just want to point out a couple things right as we start here. One is, and really the main thing is that all the parameters that you're using have to do with which side is longer and which side is shorter. So the A, for instance, that A doesn't always go there. A is under wherever the major axis is, wherever the longer is. And the B here is not always under Y. It's always wherever the shorter one is. But the H's and K's, they don't move. Because that's just not the way this works. So for instance, we've got a C right there, and that's on the major axis. That's the distance from the center to the focus on the major axis. So you always have to keep track of whether or not that the major axis is the y-axis or the x-axis. And that is going to be based on which of these numbers is bigger. So if you have blah, blah, blah over 16 plus blah, blah, blah over 64, x minus h and y minus k. I should have just done that at the beginning. I am so tired. It's just going to be crazy. It's going to be a weird video probably. So that is going to be your A. Your A is going to be on the y-axis, which also means, see, here's your A right there, right? And there's your C, which means both A and C are going to be, if the y-axis is the longer one, if that's the major axis, A and C are going to be on that axis. So if we go down here, this is another little set of relationships that you're going to need. And so again, this is the major axis, right? The longer one. But what you have to keep in mind is the major axis could be the y-axis or the x-axis. So if it's the y-axis instead of the x-axis, well, the A is going to be the same, right? But B and C are going to be switched. C is always the major axis, and B is always the minor axis, right? Okay. So that's the things you're going to want to look out for. And just a cute little thing here. If you didn't read this paragraph, think about that. What happens if A and B are the same? They actually, this can be combined. If A and B are the same, that can be combined into one fraction, right? And then that you can multiply. And remember, this is a 1 over there in the ellipse. This can be moved over there, and you end up getting the equation of a circle. I don't know if that was very intelligible. I don't know how much of this video is going to be intelligible, but here we go. We're going to move pretty quickly here. This is P7, properties of ellipses, and I'm going to be going back and forth probably between that other document and this. This graph shows an ellipse. What is the length of its minor axis? The minor axis is the shorter one. Doesn't matter whether it's x or y. So that distance is 6, right? And I'm just going to do a couple of these, and then I'm going to jump a level. This graph shows an ellipse. What are its vertices? So remember these points here, the extreme points along the major axis are the vertices, and the extreme points along the minor axis are co-vertices. So the vertices of this are going to be this point, which is what, 9, 0. And this is, oh, that's negative 9, 0. And this is 3, 0. And so that's going to be the answer for that one. 9, 9, 0. Oh, I almost lost my own number game there. 9, 0, negative 9, 0, and 3, 0. So there we go. Okay, clear that. This graph shows an ellipse. What is the length of its major axis? The major axis is, of course, the long one. And the major axis is 2a, which means that this distance there is a. And so that distance is 10. So 10 plus 10 is 20, which means that if this was in our equation, you would have 100 on the bottom where the a squared is, right? So 20. 20. Okay. The co-vertices, let's erase that. The co-vertices are the extreme points along the minor axis, right? Right. So that there's that, right? And so those are going to be the co-vertices. So it's going to be negative 3, 0, and 3, 0. Negative 3, 0, 3, 0. I'm telling you, if I took a plane trip right now, I would get charged an extra cost because of the bags under my eyes. Co-vertices right there and right there, the extreme points along the minor axis. Minor axis is the shorter axis, major axis is the longer axis, and I'm going to jump a level. What is the length of the minor axis? So let's go back here and look at this. All right. So we're looking at this, and what do we notice? And you gotta, one of the things you do have to keep straight is that A, B's, and C's don't necessarily, we learn the Pythagorean theorem in the form of a squared plus b squared equals c squared, right? But in this formula, in the way the ellipse is labeled, in the way the ellipse is labeled, the hypotenuse is a, right? When you're building, if you're trying to find out one of those numbers, notice that the length there equals that a is the same as that a in terms of its magnitude. But the thing to notice is that it is b squared plus, it's for ellipses, it's b squared plus c squared equals a squared. So don't let that throw you more than once or twice and you lose a lot of points. All right. So there's that. What else? I don't even remember what the question was. Let's see. The length of the minor axis. So the major axis. The major axis is this one. So the major axis is always 2a, and the minor axis, because there's a right there, right? So twice that, and then the minor axis is 2. That's b. So the minor axis is going to be 2b in length. And remember, b is always the shorter one. It doesn't matter whether it's under the x or the y, right? So let's go back here, and it says, what is the length of the minor axis? So that is going to be the shorter of the two, 8. And remember, that is, so 16 is the quantity b squared. So b equals the square root of 16 equals 4. That's the length. So 4 is the length is half the length, right? For this is what we call the when we can write, it's called the semi-minor axis because it's half the length, right? If you have this ellipse and there's your minor axis like that, this number there is right here, 4. So the total length of the semi-minor axis is 8. Okay, let's see here. What are we doing here? What is the center of that ellipse? Well, what is the formula for an ellipse? It's x minus h squared over a squared plus y minus k squared over b squared, and these, of course, can get switched, equals 1. And so we look in that and we see that the numbers and the places of the h and the k, remembering that they are both have a minus sign in the equation, so that's just 0, 0. Right? Okay. What is the length of the major axis? So that is the semi-major axis squared, because that's going to be a squared, right? So if a squared equals 9, a equals 3, that is the semi-major axis. So the actual length of the major axis is going to be 2 times that, or 6. What is the center? Again, h and k, right, which are 0 and 0. All right. What are the vertices? So now we got to start to think a little bit, and I'm going to tell you this straight up. The best way to do this, I mean, if you develop a great intuition, that's wonderful, but the best way to just make sure you get it right is, until you're super sure, just write it all out, right? So I'm looking at this, and I can already see h equals 0 and k equals 0. So the center is 0, 0, right? And now I got to figure out my A and my B. So A is what? A is the square root of 36. So A equals A, like that, is 6. And B equals the square root of 8. And we do not need the B. And the reason we don't need the B is because that's on the semi-major axis, and the vertices, and we're at that's where the co-vertices are, right? So the vertices, so let's just, the X is the major axis, so we can just draw some sort of basic ellipse with the center at 0, 0 right there, right? And then we know our A. Remember that A is the distance from the center to the vertice, right? A is the distance from the center to each vertex. So the vertices are going to be, if A is 36, A is 6, then it's going to be 6 in this direction and 6 in this direction, right? And that is from 0, 0. So that means it's going to be -6, 0, and 6, 0, unless I got it wrong. I didn't, so that makes me happy. All right, now we got to find the foci. Ooh, and honestly, if you get all these right, you're practically, you've mastered everything you need for all 3 of these three of these exercises because, well, that's just the way it is. Okay, so the foci. So what is this? The major axis on this is going to be the x-axis, right? Because that's got a 24 there. So, and a 20, but that's not much smaller. So it's fairly roundish. So I'm going to do this. And then I'm going to just start, that's the major axis right there along here. And I'm going to go the center. Well, I'll write it out because I'm teaching. H equals 0 and K equals 0. So the center is 0, 0. And it's asking for the foci, which are going to be along the major axis. And I'm just going to stick them somewhere. This has nothing to do with where they really are. I'm just putting them in there so I can keep track of what I have to calculate, right? All right, so now we got to figure out how to get to the number that is going to get us to the foci, right? So the center is at 0, 0. And we know that the y is 0 for both of these. So there's something, 0, and something, 0, right? Because they're all along the major axis. Now let's go back over to that other document. Well, let's put down what else we have first, right? We have our A. Oops, that's not what I want. That's not the color I wanted. But too bad now because I don't know what eraser is. We have our A squared equals what? 24. And our B squared equals 20. Right? Which means A equals the square root of 24 and B equals the square root of 20. And now we got to go figure out what we need to do is find the distance from the center to the focus. So let's go back and take a look at this and see what we got. So what numbers do we know? We know A, and we know B, and we need to find C, right? So that's not too bad. It just gets a little tedious after a while, but we have to remember that in this case, B squared plus C squared equals A squared. It is the Pythagorean theorem because it's just different letters, right? But we just got to remember that when we're using it here. So it's going to be B squared. Oopsies. I might not keep that there. Okay, I like how that follows. So it's going to be B squared plus C squared equals A squared in terms of the way we have this labeled. And we know A and B, and we're trying to find C, right? So C squared equals, what's A squared? A squared. They gave us A squared and B squared because that's in the formula, right? So we're just gonna put those numbers in, right? So C squared equals 24 plus 20. So C squared equals 44, which means that, and now I gotta go over here, C equals what? The square root of 44. Well, that's not very nice, is it? Let's go back over to the other one. Take a look here. Make sure we're doing everything right. B squared plus C squared equals A squared. B squared plus C squared equals A squared. So C squared equals, no, I did it wrong, didn't I? Look at me. Good thing I checked. See, now there's a perfect example of why you need to double check your work. This I did incorrect. It's B squared plus C squared equals A squared, but that's what I did wrong, right? Because I'm trying to find C squared. So I need to go C squared equals A squared minus B squared. What a rookie error that was, right? So now, blah, 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 blah. So now we're going to go back over here and we're going to go C squared equals A squared minus B squared. So c squared equals, and what's a squared? It's 24. Minus b squared is 20. So c squared equals 4, which means c equals 2. So now we know that this distance right there is 2. So we start from the center, which is 0, and we're going to go 2 in the positive direction. So we're going to go 2, comma 0, and then we'll go 2 in the negative direction, negative 2, 0. And there we go. And that's probably long enough for that video. Let's just see what is the length of the major axis. So the major axis is already up there, right? We've already done this once, or twice, or 3 times. That's our a squared, right? A squared equals 100, a equals 10. The major axis is 2a, so it equals 20. I am just tuckering out. So there's the center, there's our H and our K, but those have to be minuses. That means the center has to be a -1 to get this plus right there, right? Because there's supposed to be a minus in the equation. So that's going to be -1 comma 0, -1, 0. Foci of the ellipse, we already did that. Okay, so I'm gonna end this video here. You remember that if you're doing this and you get stuck, just go back to this thing. Everything you need is in there. Oops. Everything you need is in here. All the different definitions are in here. Major axis, minor axis, A, B, eccentricity. Vertices, just look for your A's and B's and C's and how they all relate, and you will just be fine, and I will help you, and you'll get this, and you will become the master of the ellipse. And that's all I have to say about that, so I'm stopping the video. Goodbye.